Hello again, everybody. Welcome to another fun-packed, fun-packed stream of making stuff happen. Right. Hope everybody had a nice weekend. I certainly did. I was in the mountains. There was rivers and everything. It was great. Right. So, what was the last thing we were doing? Quick recap. What are we trying to do and everything like that? On the last stream, there was a bunch of refactoring that needed to happen. That's done now. I'm not going to go through all the details, but next time we look at that bit of code, maybe I'll go over some of the refactorings that happened. But suffice to say, it's better now. Okay, so we're trying to solve some of the workflow sort of side of things with all this pick and place malarkey. Let me see if I can open up one of the previous diagrams. I've got a bunch of things open, but not this particular diagram. Okay, let me see if I can find it, and then we shall get right into it. Okay. Yeah, here we go. Right. So this is sort of, the overall scheme of things that we're trying to sort something out for. Let me see if I can just so it fits on the screen, yeah, something like that. Where we've got a bit of pick and place machine software, well, a lot of pick and place machine software that takes EDA design files and some other data from whoever's trying to build something, and then spits out some files that the pick and place machine can use. One of the things that you often do when you're making PCBs is deal with panels. What's a panel? All right, here we go. So, a panel. First, you start off with a design. Yay, it looks like this. And you end up with a circuit board, which looks, something like this. And this is what your PCB fab makes. But the problem with this PCB, for instance, it is actually too small to fit in the pick and place machine. Because the pick and place machine has guides on the side of it which hold the PCB. And the guides have got like an overlap on both sides. And if you try and grab it, it won't be able to grab it. It'll just slide around and you won't be able to do anything with it. So what's the solution? There's a couple of solutions. One is put a board around the whole thing so that the pick and place machine can hold it. Okay, so that's basically like a single board kind of thing. The other solution is to make one PCB that's got lots of copies of the same PCB on it. What does that look like? Here it is. This. There we go. So that's that same PCB, but in panelized form. Now, normally when you're making a panel, you say to your PCB fab, I want some rails around the edge and they need to be this big, and the type of cuts that they use are this kind of cut, so you can go like edge routing or you can go V scoring and things like this. There's various different ways of doing the panelization, but the actual method that you're using the panelization isn't particularly important for the pick and place machine, because it basically just cares that there's things it has to put down and it needs to know where to put them. So that's the bit that we're interested in. So let's get rid of this and go back to this. And if we were to have a quick look at one of the Gerber layers, such as the, where is it? Top assembly layer, for instance, preview that. Right. This is essentially what the pick and place machine kind of cares about. And let's have a look at one of the other ones. Yeah, that's the main one, really. Yeah, okay, we'll go back to that. So this is the kind of thing that the pick and place machine kind of cares about. It cares that there's a component which goes down somewhere and it has a center, a sort of pick center and a place center, and they can be different. Yeah, they can be different. They can be offset from each other. It doesn't necessarily have to be in the middle. But for a panel, these placements get essentially duplicated. So the machine comes along, and there's a few ways that you could organize your placements. You could do the same part on all the boards, one at a time, and then go to the next part and put it on all the boards, one at a time. or you could fully populate one board and then fully populate the next board. There's a few different ways of doing that. We don't care about that right now either. What we care about is that there's multiple copies of the part on a board. Not only that, but we care about what side of the PCB we're doing. As in, if it's the top, then it's simple. There's no transformations to do. There's no rotations or flipping the board and all that kind of thing. So we care about what side of the board we're doing, and we also care about the orientation of the board. So in your EDA design tool, I've got an orientation where X is to the right and Y is to the top, and 0 is your bottom left, essentially. But it may be that your PCB fab rotated the board when they made the panel. And there may be reasons to do this, in that it might make more sense to make a wider panel if you rotate your design around its longest edge, around the length. And then not duplicate it as many times on the shorter edge, for instance. There's a bunch of different reasons why you might do it. Maybe there's test pads like off the side of the board and it's easy to get to them or whatever. So you got rotation as well. So we'll ignore all this stuff. Blah, 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 blah. Okay, so let's have a quick look at the panel that we just had a moment ago. So this is that same design panelized. And we can see a few things from this diagram, this drawing, in that it's got a rail around the edge of it, and it's got fiducials in the corner. In some of the corners, there's some fiducials. And normally on a panel, one of the fiducials isn't in the same place. So you can see this one is the same distance from the left edge as the bottom one is from the left edge. And this one is the same distance from the right edge as this one is from the left edge. But this one up here is in a different position. And the reason for that is so that if you got this circuit board and you put it in the machine upside down, you could identify and tell the user that it was, in fact, upside down. So there's normally one that's offset. So when you're setting up the board in the machine, you basically find the 3 fiducials that are the normal fiducials, essentially. So that if the machine can't find those 3 fiducials because it's the wrong way up, it can tell you. So, right, yeah, so panelization, that's sort of like brief overview of panelization. So, yeah, the EDA tools can do the panelization for you. So you can sit there in your dip trace tool and do the panelization. But this isn't always what happens. Sometimes you have a design and you send it off to a design factory and you say, make the boards for me in the cheapest way possible. And they'll give you an EDA file back and you'll just use what they created. Or maybe you don't have an EDA tool that supports creating panels because some of them don't. Or maybe your EDA tool isn't very good at making panels, which is the case for dip trace and my use. Other tools are better at doing it. So sometimes you just don't even, you can't create the panel yourself to give to the fab. Other times the fabs have sort of special requirements on it and you can't meet these requirements, so you just get the fab to do it instead. Yeah. So what we need is a way to create essentially the concept of a panel in the pick and place machine software that we're creating as part of this workflow. And we can say the design is already panelized, here's the panel, or the design is a single file that has not been panelized, here's the file. And then it has to work out the placements regardless either way. Later down the line, sort of much later down the line, once you've actually worked out, the details of a panel, you're going to need to be able to say, okay, when you're making this panel, don't place any parts on the 6th one. So for instance, say this one over here with the mouse in the top right hand corner. When the PCB fab made the panel, there was problems with this board when they tested it. in those layer with a problems with the vias or something like that, right? Or there was a short circuit between two of the nets, or it got scratched or something like that. It can happen. And sometimes even when you receive the boards, you can do something accidentally to them yourself. So you need to be able to tell the pick and place machine, don't put any parts on any number of these ones. And this is often the case if you're making up prototypes, because sometimes your panel will have like 6 or 10, but you don't want to make 10 because it's costly if there's a mistake. You just want to make, say, 2 or 3 or 4 or something like that, so that you've got enough variance to find some errors, and then if one's wrong, you can check another one. So sometimes you just want to make like 2 or 4 or whatever. So you need to be able to tell the pick and place machine to skip these things. But we don't have to deal with that yet, but it is something we're going to have to remember that we need to do when we're going to start creating all this sort of like panel and job kind of stuff that we're about to do. So yeah, panels. Okay, so panels. So yeah, as part of doing panels, there's some things that we need to think about. Let's bring up this. Let's just make some notes on here about panelization. All right, so some stuff that we need to do. Orientation is one of them. Okay. One of the things we do is it's sort of like essentially design origin. Design origin. Now, some crazy people out there in the world also do another thing where they say, all right, build me a panel, but put 2 of these on it and 4 of these on it. So they have different designs per panel. And that's pick and place machine life is interesting. Whether we want to actually support placing multiple designs in like one job, I don't know. Other software I think does it. I think OpenPnP might do it. It's not. I personally don't need it, but I know other people probably will. But at the end of the day, it's not that bad, because basically you just need to load up placements for one design and then placements from another design. And then each of those placements has a coordinate, and you apply the same sort of transformations to it. So you essentially have the EDA origin and the panel origin for that design, and there's an offset for each one. So creating the panel of this, and creating the borders and creating where all the placements are, isn't too bad. But we'll see. We'll see how it goes. I don't think it's too bad. Feels like a known quantity to me. So different designs per panel. Yeah, what else we got? Design origins. Yeah. So when I'm talking about design origins, in your EDA tool, let's bring up this one. Okay. Apparently I'm weird, but I have my reasons for being weird. My design origin on this board is here. It's not down here in the bottom left, and it's not up here on the top left, and it's not up here on the top right, and it's not down here on the bottom right. It's here. It's in the center of this one of 2 boards. Right? It's here. And there's reasons for doing that. In particular on this design, the reason for doing that is so that when I click on this and then look at its X and Y coordinates up here, and then click on this one down here. Oh, clicking on the wrong screen. And then click on this one down here. We can see, if they're placed properly. And in this particular case, there's a slight offset of 0.05 there, which I think is actually probably an error, but there we go. Never mind. And you want to know sort of how far things are away from the origin, and like some components you want to be centered on the board. You've got a Y of 0. And then if you've got an offset that's in the middle, it just makes things like that simpler. So there are reasons for doing it, and like this chip here again is my EDA tool has got like floating point rounding errors on it, but whatever. And things like this 0, centered on the board, centered on an axis basically. So when it comes to panelization, what you care about, it turns out, and let me see if I can draw this. Yeah, let me do a little snippy so that we can edit this. Here we go. What we actually care about is the offset between the EDA center and the placement 0, 0 coordinate. It's this offset, as in this distance on the y-axis, right? And this distance on the x-axis. That's what we care about. And this is a EDA origin to placement offset. So let's write that down. EDA origin to placement offset. Or it's sort of placements offset, in fact, because they all get offset by this weird amount. And I've experimented with dip trace, and when it exports placement files, which I will try and bring one up now, these coordinates here are an offset from the bottom left. Not only that, but in your EDA tool of choice, you can actually set design offsets as well, which you may have done when you exported the file for whatever reason. So let's write that down. Right. There's quite a lot. There's quite a lot to this. Yes, Commander Guy says X outs, which is for the instances of a design on a panel that you don't want to place. They're called cross outs, because sometimes what happens is in the PCB fab they mark them with a marker and says cross them out. Say don't use this one. They use like a paint pen or something like that to do it. But they're not always crossed out, and sometimes the panel itself is absolutely fine. It's just you as a person don't want to put anything on those things. So calling them cross outs is not really the right thing for a pick and place machine. Yeah, naming. Yeah, we can come to it. So design offsets, right? So these are some of the things that we need. What else do we need? Oh yes. Yeah. Okay, so we've got design rotation. And then for rotation, yeah, there's a bunch of different ways of rotating an entire set of coordinates. Like, what's the rotation center? And various rotation related offsets. So for instance, if you've got this board with a rotation center here and you say rotate it all 180 degrees, right? So then what happens is all of these parts over here then come over to the other side over here, and then your initial sort of like placement offset is now sort of down here. But then do you need to then shift it back over to where it was so it's sort of rotated in place, as in what are the design extents, and is the rotation center the halfway between the design extents, or is it the origin? There's a bunch of different ways of doing it. I've done it a way in the past, and I don't even remember which way it was. I worked on it recently in my PnP convert tool, and I think I used the design extents, which presents a problem. It presents a problem. The problem is that your placement file looks like this. What's missing from here? The design extents. So you don't even know the design extents. You don't even know the design extents. Great. So somehow we need to get those from something. What can you get them from? What can you get them from? Can you get them from, let's have a look. Can you get them from a Gerber file? Because that's essentially what we're dealing with, right? And it's common across all of the tools. So if we look at the Gerber files that we get, top assembly, nope. No design extents here. You know, there's no box around it all, right? So that's no good. Can you get it from the board outline? Probably. That's what we need to look at to get the design extents. Once you've got that, you can work out the center of rotation for all the components. Okay, great. Great. So now, you know, do we ask the user for the design extents? Or do we read Gerber files to find them? God, they're so much fun. From Gerber files or ask user. It would be nice to say, here's the Gerber file for the design, and it magically finds the appropriate layer that contains the board outline, and then it can work out where the rotation center is. Be great. In my other tool, I did not write any such form of Gerber parsing. However, in Rustland, shall we look together? Here we go. PCB panels. Some examples of PCB panels. Let's have a look to see if there's a Rust crate for parsing Gerber files. Well, this. Oh, it's been archived. Oh, it's been archived in February this year. Someone gave up on it. Damn it. Repository not found? Well, that's no good. Okay, well, let's go to crates.io and type Gerber in. Gerber parser. Okay, let's see which one of these has got the most downloads. Maker panel. I'm kind of curious as to know what this is. Interesting. Probably spits out Gerber files. Let's have a look at Gerber types. Gerber types. Gerber parser. Okay. So interesting. So there might be some pre-existing Gerber parsing code out there. So it might be nice to try and use that. You know, and it might be something that we want to help out with. Yeah, because it's going to be pretty useful to have some kind of like Gerber rendering stuff. I wonder if there's a Rust implementation of a Gerber viewer. There aren't a lot of decent Gerber viewers out there. Gerber renderer. Yeah, there's quite a few other. By Gerber. Can we filter this by language? Rust. Interesting. Oh, there's apparently an implementation of Gerber parser here. So we've got some references that we can look at. So interesting. Let me just bookmark these two. There we go. Jobs are good in. All right. Let's have a look. What else are we going to need for this? Yeah. Well, some coordinates. So each placement has a coordinate. Now, let's look at this. So, you know, these are the coordinates. And in our code base, for the definition of a placement, we do not yet have any notion of a coordinate. So, you know, doing some panelization, and this is one of the reasons why I'm picking panelization, will force us to add these extra things in that we need. Coordinates. Let's write placement coordinates. Probably like that. The commander guy says, how do you want to deal with round, generally non-square boards? It doesn't. The physical outline of it doesn't matter, because the essentially you've just got to design rotation. If you put it in your machine and you stick it to the bottom of the machine, for instance, and it's not perfectly aligned, it's just like the problem is finding out the orientation of the board when it's in the machine, which you can either do with fiducials or parts in the furthest corners that are 3 parts that are as far away from each other as possible. Once you've got that, you've essentially got points that you can use, reference points that you can use for 3-point calibration algorithms. So it doesn't really matter too much. Equally, you could also get a bunch of like circular boards, for instance, and stick them on the bed of your pick and place machine, and then tell the software where each one is as part of the job. But that's not really panelization. That's sort of job setup. But there is some overlap there, because you have a job, and the job is to place X amount of boards of various one or more different designs, right? So there is some overlap between randomly placing individual boards on the bed of a pick and place machine and a panel. And we do have to be mindful of that, it's true. Let's write that down. Let's say, remember that panelization and placement of multiple random multiple random designs on a PnP machine bed are related. For panelization, I think the output of like a panelization part of the workflow, it might make sense to draw some of this up actually, just do a little sketch. I think the output of a panelization is probably going to be some form of job. And the job will say, I want this design, because you've got all your part mappings and all that kind of thing, your assembly variant, right? I've got this assembly variant, and it goes here on the bed of the machine. And then I've got the same assembly variant, and it also goes here on the machine. And each one of these could be, slightly different. If it's in the panel, all the alignment is going to be same or offset by equal amounts and so on. And part of the job will be to either find the panel which contains all of the designs, or find the individual PCBs that you want placed. But that's sort of like a second stage to this. But we need to have a source for this later process to work with. We need the concept of a design, like an assembly variant or something. And then we also need the concept of a panel. And once you've got these things, then you can do sort of like the job setup. Yes. Yes. Something along those lines. So. Righto. Yeah, let me try this little thing. So I guess if you've got a design and you've got a job and you've got a panel, what am I doing? And you might have multiple ones of these, right? And you might have that goes sort of that way. And then also, I don't know, your job might be to place two panels that are next to each other in the machine, to be honest. I personally have never done that. Arguably, it's just a list of things that need to be put on some PCBs in a machine, and the machine doesn't care whether there's two panels in the machine stuck to the bed, or two panels in the machine that were loaded in on a conveyor belt at the same time, and they were both placed at the same time. The machine doesn't really care. And then you've got a job. And the job can take some of these or some of these, right? Something like that. There we are. Great. Save. Something like that. But we're dealing with the design and the panels side of things right now. Right. Panelization with a Z. Yeah. See, the thing is, I'm English, and all my things are set to English spelling. But my head, I use the Z because that's how you say it. You don't go panelization, you go panelization, don't you? So the Americans win on that. Right. So design extents, blah 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 blah. Placement coordinates, and the other thing that I briefly mentioned earlier, which I didn't write down, is the placement side. And then we need that, and we also need the design side as well. Okay, because you say to the pick and place machine system, you go, I'm doing the top of this PCB. But the placements in the placements file have a side associated with each placement. And when you're exporting your file, you can create one file, and there's often a side column which can either be top or bottom. So you've got placement side and design side. So this is sort of the main, I guess it is, that we're dealing with here. I'm sure there's probably something I've forgotten off the top of my head, but it'll come to me. And there's certainly stuff here we can start thinking about and writing code for, and so on. Design origin, design extent. Let's have a quick look at my old software. Because that might jog some memories. Yeah, okay, so PNP convert hydro. Oh, what happened to that? Oh, I don't know. Okay. Let's have a quick look at this. So these are, the arguments that we were using in this little tool that we used. So this board to bottom left offset is that EDA offset that I talked about. Board thickness, yeah, we'll come to that because we've got to deal with the Z height on all this stuff at the moment, but we don't care about that for rotation and orientation. EDA offsets, talked about that. EDA origin, talked about that. Yeah, design extents, talked about that. Board width, essentially, and board height, yes. But say we'll exclude. We've got stuff to do with feeders. Yeah, those are sort of the most of the panel. Oh yeah, here's the other ones. Here's the other ones. Yeah, so in this tool, it only works for panels that have got the design repeated on set X and Y intervals, which is normally how they're made. It's normally how they're made. And for rectangular boards, or boards that can fit in a rectangle, the interval is fine. However, there are different approaches to telling the fab how to optimize the PCB material that is wasted for PCBs that are not rectangular shaped. So, for instance, if you had a bunch of triangles, the way that you would tessellate those, you wouldn't tessellate each one of those into its own rectangle. You wouldn't put the triangle in a rectangle and then tessellate the rectangles. You would take one triangle and then you would rotate it probably, 180 degrees, and then put it next to the other one, and then edge root the edge of it. And that way you waste less PCB. And we have to remember that PCBs, you order them by the area. It's a cost per area, cost per square millimeter. So tessellating things and how you tessellate them is important. But that causes a problem if you're using an interval, a distance between the first one and the second one. In the case of this board, the interval is the same as the design extent, sort of like height, essentially, the y-axis, right? Because it's v-scored. But other ones, they need to have a gap between the circuit boards. And reasons for doing that would include like component overhang and things like that, right? Or just that you want a nice smooth edge on the edge of the board in some bits, or you don't want to, or you can't break it. You're not allowed to break it because you're using MEMS parts, and they don't like the snapping forces for separating PCBs. So you need to edge root them. Yeah, so you've got the interval. So the interval includes sort of like the spacing between each board. There's the simple way of saying that you have a set interval, or you can have another sort of algorithm for determining where the design origins are, such as a staggered and rotated or a manually determined. So let's write that down. I mean, like we've got design origins here. But essentially, you need to know the design origins, but the software can help you find or calculate the design origins from some set parameters. Yeah. Yeah, design origins. Interval, so X, Y, interval, and then staggered and random, let's say. I don't know. Maybe someone was really bad at creating their panels and there was no set interval when they did it because they placed it manually and there was like some error when they placed the instance. I don't know. I guess it's not random. It's random's not the right word, is it? What's the right word for that? Don't know. Yeah. I don't know. Anyway, some concepts. Okay, back to this. So intervals. So we talked about that. Yeah, and then the number of PCBs on each axis. Yeah. That's a bit weird. I think there's a typo here because I've got this twice. We're not going to worry about that today. There's a good reason why we're not going to worry about that because I archived this repository. Right. So panel number, yeah, the quantity, I suppose. Let's write that down. Design origins. Yeah. I suppose really we should write designs down because that's sort of like an instance of a design. And then we'll say design quantity. As in there's X amount of this design and there's Y amount of that design. E.g. 2 of design A and 3 of design B. A, B, etc. Yes, so we've got orientation, but there's two types of orientation. There's yeah, design. We've got orientation of panel and design rotation. Yeah, no, we've got that. That's fine. Okay. Yeah, and I've got this. I have this concept of like rail width. The idea behind that is that you say, I've got a panel, and you want to represent that panel on the screen, given only the Gerber files for the designs, and you want to draw that panel on the screen and say this is what it's supposed to look like, so the user can visualize it and see if it looks right, and sort of visually verify that what they've got in their hand and what's on the screen match each other. If you don't say how big the rails are, you can't really draw the rails sort of on screen very well, or a representation of the rails on the screen. Let me see if I can quickly dig out an example of this. Should be able to find one for the one we just did. Top SVG. Yeah, here we go. Right. No, Microsoft, no, never, no, no, no. So this is essentially sort of like the pick and place representation of. I move it across to a bit. Yeah, this is the pick and place machine's representation of this. To switch between them a couple of times. Right. So the purple is the edge of the panel, and the green is the design extents. And then if we look in this corner over here, we can see the individual placements. And we can also see a couple of other things on here, which are the X and Y coordinates, sort of like panel offsets, as it were, panel numbering, which is important because you need to know which panel was where for like QA and like other weird reasons, such as if you're doing pasting and then you find you've got QA issues with a bunch of boards, you need to know where they were on the panel. And if when you take them out of the panel, you mark them up with their coordinate. And then if you've got, say, problems with all the boards that were on the left-hand edge of the panel, you can then correlate that with how your paste machine printed the paste, for instance. So I have a problem with my paste machine, and it's one of these stupid hinged ones. It's not a parallel lift one, right? And the stupid hinged ones, what they do sometimes is they smush the solder paste forwards as the hinge comes up if it's not quite right. So it's important to know where the boards are, and therefore you need like the panel sort of like number and coordinates. Yeah, and then we've also got, and I talked about this a little bit earlier, which is on the pick and place machine representation. We've got the fiducials here. We've got those three fiducials that I talked about. So FL to me on my naming convention is front left, front right, and then rear left. And these orientations are as you put that panel in the board, the front left appears in the front left of the pick and place machine. But whatever works for like how you name them, it doesn't really matter. It's just a tag. Anyway, so yeah, so what do we got here? So let's write some other things down. So we've got rails and fiducials. And we also said design coordinates. Let's say design numbering. In panel. Yeah, okay. I don't know why I'm putting full stops anywhere. Sometimes I do these things. Right, let's have some more full stops. I'm never going to get that part of my life back, am I? Right. Where do we start? Where do we start with all this? Honestly, we could start anywhere. Let me think about it. We could start by defining a panel in code, I suppose. It seems fairly reasonable. Do we care about the panels yet? Do we care about the panels yet? I suppose we do, because if we don't care about the panels yet, then we've got no reason to add the coordinates or the side into the code base, right? I suppose also we need to have something that requires us to need a panel. Let's think about that for a moment. What needs a panel? Why do we need a panel? The reason why we need a panel. Okay, I'm glad I drew this now. The reason why we need a panel is this. you can create a job that has a design, or you can create a job that has a panel, apparently, because that's what I designed a minute ago. Right, the title of this video is Panelization and not jobs. Do we want to start defining a job at this point? Do we have designs yet? No, not really. We just have a bunch of placements. Yeah, all we have. Let me bring up the other diagram. We have this. This is what we've got right now. Yeah, something like that. Can I move this across? Yeah, there we go. Yeah, I guess that didn't really help, did it? That's sort of what we've got at the moment. We've got our placements from our EDA tool, and then wait, hold on. Mapped placement. Yeah, we get a bunch of mapped placements. So the input to our tool is basically a bunch of CSV files and an EDA placement file. And the output of our process is some mapped placements. And these mapped placements don't have anything useful on them at all. Let me just bring up the test so that we can just refer back to that for a moment. Tests, variant builder. So the output of our main test, which was this dip trace one. So we start with a bunch of placements. And eventually we say, this is what we expect to happen. And then after that, we end up with a CSV file. And we're only sort of, we don't really care about the contents of the CSV file too much at this point. It's just sort of like a temporary thing to allow us to force us to write some code. But we know we want these placements list out of that, and that's going to go into this job side of things soon, I suppose. And currently it's got reference designator, manufacturer part number, and place field. And then eventually it's going to have like coordinate and X and Y plus the side, which will then feed into like some job processing thing. Multiple times, I suppose. Once for each design that we're supposed to be placing. Yeah. So why do we need a panel? Well, what can we write? What can we write that's going to make us need a panel? I suppose if we defined a job. Yeah, okay. So one of the things that PnP convert does, it essentially creates a job file for the machine to work with, right? It creates a job file. That's its whole purpose. So starting from a job perspective is probably the right way to go about this. So if I want to create a new job, what does a job output look like? On my old machine, it would be essentially okay, let's have a look at one. Have a look at. Let's not talk about it. Let's just have a look at one. Right. Can we bring one up from here? Let me see if I can drag one of these into an editor. Let's drag it into here somewhere. Let's get rid of this. let's see if we can do this. Now, obviously this is very specific to how the Charm High pick and place machine works, but things in it will sort of tell us stuff. So this is a file, for instance, that one of the files that was created. So part of this is to create multiple jobs because annoyingly, this particular design had some parts which were too tall for the pick and place machine, and they had to be placed manually after in a method that prevented them from crashing from the head, picking them apart, and it crashing into the other parts it had already placed. So it had to be split up into two jobs. Other reasons why you have to split up a design into multiple jobs is because there aren't enough feeders on the machine to actually place all the parts in one job. So you have to basically place a bunch of parts on it, then change the feeders, and then place a bunch more parts on it, and then change the feeders again, place a bunch more parts on it, then take it out and reflow it, turn it over, and put some more parts on the bottom of it in one or more jobs. Okay, let's write some stuff down to do with jobs. Panelization. Jobs. What do we know about jobs? Um, What does a job contain? Let's look at this. One or more designs and one or more panels. Let's just write one or more designs, one or more panels. And then, well, so how do you, yeah, you see there's job and sub job to me. The job is to create is to perform a bunch of placements on a set of boards that are in your pick and place machine. Okay, let's change this. One or more sub job. How about this? And then a sub job contains these things, right? And I guess a job needs to know stuff about like orientation of the panel in the machine or orientation of designs, or one or more designs. Yeah. Assignment of parts, I suppose, parts to designs, as in I want to place all the cheap 0402 resistors as part of the first sub job. Then I change my feeders. Then I place a bunch of capacitors in the second job, for instance. And then in the third job, I place all the expensive components. Let's write an example of that down. E.g., 0402 resistors for all PCBs, I guess designs, then change feeders, then place 0402 caps, change feeders again, place remaining jobs. Yeah, okay, I'll write that down under here. Subjob example scenario. Yeah. Sounds about right. So assignment of parts to designs. Right. Okay. Sub job. Fine. Oh, this gets just epically complicated, just like straight away. This is what I'm this is what I'm saying. It's like a pick and place machine. It's just part of the workflow. Just part of the workflow. All this stuff. Yeah. Righto. Moving on. Right. What are we doing here? What are we doing? So what's the output of a sub job? An ordered list of placements. Now I wrote the word ordered down there because that's very important. There's also another interesting thing which I'm thinking about as well. In that you only want to specify the location of the boards on the bed of the machine once. And I guess you can't. See, one of the things that's a bit weird here is that the knowledge of where something is. I mean, it also depends on what we're trying to create here as well. The knowledge of where something is in the machine is the responsibility of the machine. But we're trying to replace this software. It's fine. I mean, everything's fine. Right. Question. Here we go. If you run the same job on multiple physical boards, they might move around a bit. Yeah, this is what I was thinking, right? In that by the time you get to place the second sub-job's components, the board might have moved around a bit. Okay, but ideally, the pick and place machine should just be able to find where the board is before it places the first component on that board within a margin of error by using the fiducials, and this should happen automatically. Right? So you put all the boards in the machine on the first job and you say, this is where all the boards are. And then you come to the second sub job, and then it should use the knowledge of where you told it they were, and then look there to start with, and then if it can't find the board there from its three fiducials, then go, the board's not here, and beep. Or adjust itself just slightly so that it does know exactly. So if we say job needs to contain the location of each panel or design on the machine's bed, right? Then when you come to do the sub job, you can use that information and or update it as you progress. That feels about right to me. That does. Yeah. Righto. So, sub job. One or more designs, one or more panels. Right. Right, subjobs. Yeah, okay, so let's deal with the panelization X outs as they're sometimes called. I'd like to use a different name for that. Maybe we should just use X outs as the name. It's essentially a skip, essentially. And then for a given panel, you might want to skip it X amount of times. You might want to skip. Now you see we've got a problem here. Because you can't have the location of each panel or design on the machine's bed unless you know what the designs and the... Yeah, no, these can't go here, can they? They have to go here, right? They have to be part of the job. Yeah, okay. Okay, that's probably fine. One or more panels. I guess it's a list of designs on a panel to skip. I guess this is X outs, right? AKA X out. Yeah, seems about right, I think. What else? What else do we need before we can start cutting some code? I think there's probably enough there. I think we can probably start writing some code at this point. Dangers of writing code too early before you've thought about the problem. Yeah, it's one of these things where there's a lot of different ways to do all this stuff. I think we've got the main part of what we want, the concept of like a job. Yeah, let me bring up one of the job files. I was trying to bring up a job file. Right. Right, job file. Here we go. No, Microsoft. So in this particular case, we had two job files that were created. This is... No, wait. This... wait. Where's job one upload? I don't know where it's gone. Okay, let me look at a different design for a moment. I know this is slightly confusing. I apologize for that. Looking at different designs. But this one I know I needed different jobs with. Job 1, here we go. Job 2 and job 3. So this is an example of a board which was a real pain in many different ways. So job 1, and this is what it looked like for the software that was on my pick and place machine. It defined a list of feeders and what part was in each one. And then it defined a list of things that it should place. And you can see from here, we placed all the resistors, right? So this job is literally just 0402 resistors. The next job is another list of components, and this is mainly capacitors in here, right? All capacitors. Then it has another list of placements, and it says, place the capacitors. Here you go, do them like this. And you got an ordered list, right? And then the third one was all the other bits and bobs that needed to go on the board. Okay, so that told us about feeders. I don't really want to get too much into the concept of feeders right now, unless I really, really have to. We might need that at some point. But at the moment, we're just dealing with the placement, I think. Because let's go back to this. So for our definition of a job, this we're defining what needs to go on it and where it should be when it's on it on the PCB. Like what parts need to go here. What we haven't said is where the parts come from. So probably, and this isn't going to be something we're going to do today. Let's have a nice green. We're gonna have, I don't know. Let's write the word feeders down here. You know, I guess it's not quite like that, is it? Oh, look at this! Wow. Now we can vectors. Look at this. We're not using paint today. Oh, the luxury. Let's leave feeders here. And let's also write, was it this tool? I think it was this tool. Let's write parts here. Right? Because, yeah, you know. A design. I need another color. Not that. Click. This one. Okay. A designer's got parts. Oh, what happened there? Well, that's a bit silly. I can't see the line as I'm drawing it. And then a part goes to one feeder and another part goes to a... Oh. Let me draw that in the right place. Maybe like here and then maybe here. Something like that. And then... then I guess a job has some relationship with feeders. I guess it's like that. Yeah. My thing's in the way. Hold on. Can we zoom? Can we zoom? Can we zoom? Can we zoom using the keyboard? No. 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 Yeah, I don't know how to zoom on this with the mouse. View, zoomity, zoom. Control minus. Yeah, that'll work. There we go. Something like that. Yeah, no, I tried Control plus scroll. It wasn't that. I tried Control, I tried Alt, I tried Shift, I tried Control Alt, I tried Control Shift, and I tried Alt Shift, and it was none of those things. View, zoom. Yeah, that's a mouse wheel. It doesn't say anything about mouse wheel here. I don't know if there's any settings. This program is new to me. I've never used it before. Is there a way to search the preferences? No. Keyboard shortcuts? Oh, mouse shortcuts. Scroll? No. Zoom? Alternate? Custom? What did it do? Yeah, you can't see it. There's all this space here and you can't see it. Wait, can I resize the column? No. Okay, well, you know, cancel. I'll try and work that out later. You guys don't need to see me get frustrated with the thing of this. 25 years? Really? That's quite a long time. Well, I never. Anyway, so that's what we're dealing with there. I suppose we save that. But we don't need to deal with the output side of this right now. We don't need to deal with the output side of this. Okay, let's write some code. I think we've got enough information to go with right now. Okay, here we go. Let's get rid of this. Yeah, at some point I'll talk more about this ordered list of placements, but not right now. Okay, all right. Where do we start with? I suppose I don't know. I mean, one of the things we could start with is going to this bin thing and going variant builder and doing some stuff. Hold on a second. No. Hold on. Because I'm saying the word variant now, and there's more to it. Okay, so sure, you have a design because the design has got things like the extents and stuff like that. Damn it. We need variants on here, don't we? Okay. Okay, I think I see where it goes. Let's resize this a bit. Oh, wait, hold on. Yeah, no, I'll resize the canvas, otherwise my brush size will be wrong. How do you resize the canvas? Image. Oh, it's there, look. Resize canvas. Okay. Let's just double that. Oh, I don't know. 1080, 12, 2160 in it. Come on, look at my math brain working there overtime. Keep it top left. Thank you very much. All right, great. Background layer, unlock. Switch these and then perhaps fill it. There we go. Okay, so this one, lock that. Select everything perhaps. Can we move it? Oh dear, no. That didn't work, did it? No. Select. Deselect. Select. Oh dear. Yeah. What I'm thinking is that this bit lives over here. And then we write the word assembly variant. Oh no, not in that color. I can't see the cursor while I'm moving it around. Look, like, why doesn't it show me what I'm drawing while I'm doing it? It did earlier. Why doesn't it do it now? Right? That's weird. Assembly variant. Okay. Sure. And then you have designs, and then for each design you have an assembly variant, and then you have a panel of essentially assembly variants as opposed to, well, okay, that's an interesting question. So on your panel, how about you make a panel with 4 assembly variants on it? I mean, that seems like something you might want to do. In which case, our organization of stuff is wrong. But the good thing about a panel, though, is that for a panel, the design is still the thing that you use to work out what the extents are, where the central rotations and things like that are. But the assembly variant is what you use in order to create the list of placements that you're using. That's interesting. So essentially, a panel needs a combination of a design plus an assembly variant for it. And you need to say for each bit on the panel which assembly variant you want to place, right? Or is that just too much? I mean, it seems like a thing that you would want to be able to do. Is it too much? I mean, if you this kind of like who owns what kind of stuff is fairly critical, but the details of what the individual things are is less critical. But how they relate to each other is usually more critical. Yeah. So let's write down a scenario. Okay. Job. Um let's say I'm going to write 2 scenarios down. One panel with, let's say, 6 identical designs and 2 and 3 assembly variants for the design, and yeah, and 2 of each variant. That's a pretty good requirement, I think, to like work out all this job stuff, right? Okay, and then the next scenario is you've just got the same kind of thing, but they're not in a panel. So like 6 identical PCBs on the bed of the machine in random locations. And then it's the same kind of thing, right? 3 assembly variants and 2 of each, right? But without a panel. And each one of these may be split into sub jobs as well. Oh, what have I decided to take on? This is going to be fun. Right, here we go then. Right, I think I'm going to take a couple of minutes break to refill the Wally mug with the appropriate bean juice. Right. Okay, right. Back in a jiffy, everybody. Alrighty, we're back. Okay, so got my biscuit. No, Kevin, it does not have any gravy on it. Um, Hmm. 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 That's what we want. Radio. So what we were trying to look at a minute ago before we realised that we needed assembly variants in the job. Duh, of course we do. That's what I've been writing for the last 14 live streams. Okay. Righto. So we need assembly variants. But, you know, say you've got this list of stuff from an assembly variant. And let's just quickly remember what we wrote here. Is that we had this thing called build assembly variant, which currently is done by a bunch of steps using some components which don't live in the binary itself, and then it prints out like a tree kind of stuff, and all this sort of printing and tracing and all this kind of stuff is part of this bin file. Right, so sure, you've got an assembly variant. So let's say, okay, great, we've got an assembly variant, right? And you can, yeah, then the next step is creating your job. And you say what you want on your job. And then you say, okay, this is now how I need to load out the machine, and we'll deal with machine loadout. So we looked at the machine loadout a little bit, but as part of now the mouse wheel by itself just scrolls in and out. Why? Is it because nothing is selected? Okay, I don't understand. Anyway, so yeah, so there's going to be like, you know, what's already in the machine, and that's going to feed into all this. But yeah. So I'm thinking that the creation of a job is separate to the creation of an assembly variant. Because an assembly variant, the process of creating an assembly variant is you basically have your EDA design and you run the assembly variant thing, and then you add the parts and you create the part mappings, and then you do all this, and eventually you'll be able to define all the manufacturers and part numbers that you want on your assembly variant. And only after that point can you then even think about creating a job. So it definitely comes after. Yes, definitely only comes after. So I'm thinking what we should do is create a new binary. Oh my god. Which then takes some, you know, allows us to define some kind of job and sub jobs and can do some sort of calculation of component positions relative to the thing that was found on the machine. Place PCB, yeah. Yeah. But what does it give us at the end of it? What does it give us at the end of it? What does it give us at the end of it? Let's look at this for a moment. Great, we've got a job. Then what? What does it give us? Well, it gives us perhaps a job stage with the ordered list of placements in it. I mean, this is sort of like the output, isn't it? Because I didn't say that this is sort of input or output, but this is just like, I think it gives us a set of ordered list of placements. But it's not quite as simple as that. You see, because sometimes during the assembly of things, shit happens. And what can happen because of this? I don't know. Maybe you just ran out of some kind of part or something daft like that. It's a fairly common occurrence. Or you ran out of time, or you had issues with the machine and you needed to fix it for an hour or something, and then you're halfway through a job and you decide that you don't want to continue placing remaining designs on the board, but the first 3 that you print that you're placing were okay out of your, say, 6, right? Then do you want to be able to go to the job and say, I don't want to do this, I don't want to put any more placements on this board, on this design? Forget that. You don't really want to recalculate the entire ordered list of placements, because you're then your job, which is essentially like, and it's an order list of placements. It's essentially, you just want to say, you don't want to change what's on that list. You just want to enable or disable things on it. Chunk of these things perhaps at a time. Or one of the other things that can happen. Let's write down a list of things that happen. Stuff that happens mid-job. Time runs out. Component won't place. For whatever reason. Maybe the pick and place machine can't reliably see it and it's just too much hassle, whatever. Out of stock of components, e.g. reel runs out. Things that you need to do mid-job. Let's think about this. Disable a feeder entirely. You might realize that a component that was supposed to be placed shouldn't be placed, as in you didn't get your assembly variant right. Let's say, and this is going to be a pain, I can see it, a change to an assembly variant. Now, we might want to limit the scope of changes that you can do for an assembly variant. For example, let's say, let's say, e.g., disabling a part at a given ref des. So you want to say, I don't want to place R1 on any more of this assembly variant because I didn't define my assembly variant correctly. Okay. One of the other things you can do, which is definitely going to be more annoying, is adding or removing a ref des to an assembly variant because then somehow you need to like now re-correlate all your list of placements and your list of stuff that's on your ref dares and add things to the list and then reorder everything. Ugh, that would be a nightmare. I don't know. Yeah, that would be a nightmare. Because if you add a part mid-job to an assembly variant, right, and this part is, say, Paul, and your ordered list of placements, of which there is an algorithm to define the ordering, means that this assembly variant is placed at the end of the list. It's easy. You add it to the end of the list of placements that you've got. Fine, right? But if, say, it's like not the shortest thing and not the tallest thing, and you were ordering things by height or area and then height, which is fairly common, price, area, and height is normally a good way to order things. But it can also depend on your nozzles and things like that as well. But anyway, if you changed your assembly variants such that this new part ended up in the middle of the list of your nicely ordered list of placements, obviously then your current position through the list then needs to be changed or somehow updated to cater for the fact that it hadn't been placed yet. And, you know, yeah, adding and removing things from an assembly variant mid-job, bad. Disabling it, enabling it. I suppose you only get to disable things, really. You don't get to enable things. Well, unless your assembly variant still contained the... yeah, I have to think about that. Still contained all the placements that you need to do, but then just has the place flag set to false, then you never have to deal with... Yeah, don't know. Okay, well, anyway. Other things you need to do mid-job. Oh, well, yeah, you know. Move a part to a different feeder. That's a common one. You get a problem with a feeder, you just go, I can't load it from there. It's not working. It's not pulling the tape properly or something daft. Yeah, and then redefine a feeder. I don't know. Is that the same? Moving apart to a different feeder, redefining a feeder. They're very related, these two things are. Very related. So redefining a feeder, for instance, might be something like you got your feeder settings wrong if it's like a tray feeder or something like that, where you've got your parts aligned in a grid, and then you realize that your grid definition is not right. Redefining a feeder. I guess it's not really redefine. Let's say change feeder setting. Let's put that there. Because this is pretty common. You end up having to fiddle about with, say, the vision settings or the vacuum settings or pick position settings or tape pull settings and things like that. I've got loads of splinters in my hand from the mountains yesterday. All the plants out here in Spain are spiky. Got an annoying splinter in my finger here. I'm gonna have to deal with it after the stream. Yeah. Okay, so we need to be mindful of these things. We need to be mindful of these things. They're all very important. So let's go back and see if we can decide what we want to do. So I'm thinking a new binary, which oh yeah, no, we were still talking about the output, weren't we? I think the output is basically this, isn't it? The output of this thing. So you say, here's a bunch of assembly variants. Here's the definition of a panel, and now build me a list of placements, please. Thank you very much. As in placements per sub job. And then you can say go. Yeah. Okay, let's do that. Let's do that. Let's do that. We can write some code. Let's write some code. So we've got a variant builder, and it's a CLI tool, and it's got a main method in it. So it feels like using this as like a little template to create some new job thing. Seems like a reasonable idea. So let's create a new binary. Why not? Why not? How do we create a new binary? Do we have any uncommitted changes? No. Perfect. Binary time. Let's go. Bin. This is how you define a binary. This was ages ago we did this. Wow. Variant builder. Let's call it, I don't know, everything's a builder, right? Job builder. Is that right? Kind of. Let's call it that for now. And if we change our mind, we'll change it. Fine. Right, we're going to use all the same CLI things that we had before, I believe. Stuff to do with CSVs and clap and term tree. Yeah, no, that seems fine. So we're going to do that. Great. Fantastic. Okay. Let's create a new file called job builder.rs. Yeah, why not? And let's create a main method in it. And then we're just going to say OK. We're doing this all wrong, aren't we? Who knows what we did wrong? We didn't start with the test. Tut. Tests. Here we go. New Rust file. So we need a job builder. There we go. That's more like it. So we'll refer to our variant builder. So we're going to need some of this. And we only want to run these tests when the CLI feature is on, so that seems fine. And then we're going to need a test. Let's start with a simpler test. One of the tests we've got was the no args test. Right? This one. So let's start with that. So, yeah, comment that out. I'm going to say when we have a command. Oh, we need a command. Perfect. Oh. We have a command, it should fail. Right? That's all I know at the moment. And the command was called job builder, which means we need a command, which is that one. We've got to assert some stuff. And that's going to be it for now. We'll deal with this later. Okay, so that's enough to allow us to write the main method, right? So if we try and run this, what happens? Let's go to my launch configurations. There's this one, and we're going to duplicate that. I'm going to call it job builder tests. Sure. Go. Perfect. Okay. Now, it fails. Great. Because we said okay, right? Is that why it failed? Unexpected success. Failing test. All right, good. So then I suppose we can say, we want it to tell us what we can do. Let's refer back to our other one. So we defined our expected output, which is going to have some of this. Build is probably a thing. Let's say it's going to be build job. We'll deal with trace logging a bit later. And we want the help and the version stuff as well. So fine. Right. So then we need to do the asserts for that, which we did like this. Right. And this print method currently lives in the variant builder test. But we want to reuse it. Where do you put common integration test code? Anybody know? Anybody know? Don't know. Let's go util. I don't know. Pub mod test. Honestly, I don't really know what this is going to be called. This is where it's going to live for now. Yes. And we're just going to cut it entirely, I think, and then we'll deal with the import shortly afterwards. So now we've got this print. It doesn't know where to get it from. Great. Oh, it's not a public function. Now we can import it. Great. Which means we should be able to import it here as well. Good. Go. Prelude, yeah. Seems reasonable. But it's not called variant builder, is it? It's called job builder. Right. Right, clearly this isn't going to run. But let's see what the error is. Okay. This stuff should not live in the main production code. So if we were to say CFG, see, this is, we're going to get into cargo fun now because of this. Because the problem is that the integration test, well, at least I think it's the problem. The integration tests use one crate with a set of features. And when you're running or compiling integration test code, I don't think, but I'm not sure, that the test flag is enabled when it compiles the production code. I'm not sure. Yeah. How? You see, it's a problem. So then you sort of have to have a dependency on yourself for the binary, or a feature for yourself. I think. So if we say int test like this, and then say features int test, right? And then the variant builder says it requires int test. Oh wait, it's not like that, is it? It's like this. But that's not right. The binary doesn't need int test, does it? Oh dear. Let's undo that. It's the integration test needs it. Like how? Okay, I think we need to refer to the cargo documentation. Cargo integration test features, or shared code, because that's what we're trying to solve, isn't it? Yeah, okay. Create a shared crate, yeah. Dev dependency. Yeah, that's what I thought it was going to say. We're a test-only module. But that's what I did, wasn't it? I thought that's what I did. Let me look at lib. So lib has got all this stuff, right? Util was where I started doing it, and then int test was this, right? Oh, yeah. I mean, I did it wrong, but you know, it's supposed to be like that. Feature. Yeah, I thought I was on the right track, but okay, fine. I was on the right track. Let's oh no. Maybe it's okay. Maybe it's okay. Maybe when it builds the binary. Yeah, wait a second. What? I mean, it won't be linked into it, so... Okay. Oh, okay. Let's have a look at the oh dear, predicate. We've got, you see, but is when you compile this, like, can you also do this as well? No. I want to say only compile this bit of code if you're trying to compile an integration test. Because when you're compiling it with test mode on, you get the dev dependencies. And the production code doesn't use any predicates. So I don't want to move predicates up to here. So, yeah. I didn't really want to have to reorganize the entire project structure just to reuse one test helper by creating crates and adding crates as dev dependencies with the test helper stuff in it. You know what? I'm going to deal with this later. Maybe I was on the right track. But I think moving it is just a bad idea right now. I guess another way of doing it would be to use Rust's include statement. Which I don't really like, but... What happens if we just move this here? Because this then becomes its own crate, right? Right, which you don't want. So what we're going to do is include this from here. And we're going to say, let's rename this to just int test. And then we're going to go how do we do it? I think you go something like pub mod int test. And then you tell it, you give it an attribute of where the file is supposed to be. Path. I think it's path. It's something like, yeah, path. And then we go inc/int test.rus or something like this. Is it? How do you do it? It's something like that. No. Something like there's a list of built-in attributes. Here we are. Where's the path one? No. Built-in attributes. Path, that one. Here we are. Do we really need to do this? Because the int test is this, and it's going to think it's that. Oh, I'm specifying it wrong, aren't I? Am I? No. Why doesn't it like it? Let's just see what happens. Test. Tests. Oh, I see. Yes, it's a little bit weird. Hmm. But, God, no. No, don't try and be clever. Okay, let's move this out of here and put it here, perhaps. Let's see what happens. Okay, good. I mean, that's good. Okay, great. We moved it in a not entirely insane way. So now in our other test, without screwing up our dependencies, because we don't want to screw up the dependencies, we can move this later, but, you know. So we'll put this here. No. Variant builder. Make sure this runs still. And then we import it. Plop. Go. Unused import. Great. Goodbye. There we go. Right. Now we can go back to the other test. No, well, it's fine. And it runs. Good. Unexpected success still. So this is because our binary job builder, here he is just doing this. So it needs to have the clap. It needs to get the clap. So we need to do this opt pass thing, basically. And then in order for opt pass to work, we need opt, which has got all the things on it that we need, which is like the command and all this kind of stuff. So we'll borrow this for a moment, and then we'll think about it. We need opt. Great. We need our build command. We don't need this yet. We need to derive this for it to make clap work. We want the version and about because we said we do. And therefore, we need the name of this thing. So job builder and job builder. Okay, fine. So now we need our commands. And our commands was defined like this, where we say we want to build something. And I don't know what's going to go in there just yet. Don't know. We do know that we want an output. specifying some kind of output because we essentially want, I don't know, I mean, our output is, I don't know, this is another intermediate thing, really, this is, so I don't necessarily want to go output. I don't know, I don't want an output right now. I don't want an output. I just want to be able to say build. Okay. So this is what we got, and what we said we wanted was this. And only the indentation was wrong. I mean, that's a good start. Job builder. And this is because we don't have any other arguments and stuff. So there's 2 spaces. So it's like this, right? Oh, what else is wrong? Oh, we got, yeah, there's no options yet, so we're not going to have this. And then we need our trace options, and we're going to put that back again. Okay, so now let's deal with trace. Put that back. So what we want to be able to say is the same as we did in this. Build. No, not this. This. No. No arcs. This one. Not that one. Was it that one? Yeah, this. This is what we want. We want to say we want the tracelog output to go here. And we want the tracelog output so that we can do assertions on the output of the program from the test. So we're going to try and add that option. Thus. Which means we need to borrow more stuff from our variant builder with regards to the trace. And the trace was defined here. Job builder. Ops. Same stuff. What happened? And now the indentation has changed back again. Fine, 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 because of this. Yes, all very good. Well done. Great, so we've got our binary. Then what? I feel we should do a commit at this point, which is just like add the skeleton of the like thing. Let's do a commit. What did we do? We added a new binary. Our variant builder, job builder. Look at this. Job builder. Add. Well, like create skeleton CLI tool. Seems reasonable. Okay. What did we do? We added new thing, test stuff. Job builder. This is what it can do, which is pretty much nothing. Yeah. All good. And in order to do that, we had to move this somewhere else could use it, and then that meant we had to change this, which required changing some imports and moving some code. Fine. Well, no. Okay, we deleted a little bit of white space there, so that's fine. Don't need to tell people about white space unless the only thing about the commit was white space changes. And then we've got our new command. And we don't do anything with it apart from parse. So I suppose this probably should be an underscore here. Otherwise we get a warning, do we not? Did anybody see a warning? Yes. So we fixed that. Okay. Let's try and run all the tests. Okay. This is good. So now we're running tests for variant builder and job builder. This is good. And yeah, we still have to deal with this stuff at the moment. Yeah, not as part of this though. Okay, this is good. This is great. I think we're there. Create a skeleton CLI tool. All right. Any unversion files? No. Okay, we're done. And this seems reasonable. Let's there's not a lot of merit in pushing this to a remote repository at this point because it doesn't really do anything. But it lets other developers know that we intend to do something and not to stomp on all the things that we're doing as we're doing it. Yeah, so we're going to push it up. It's fairly atomic, right? Right, now what? Now what? Jobs, I suppose. Jobs. We need to actually do something more useful. Close everything. So we've got our no args test. Fine. But now we need our test where we actually build a job. So let's add a new test for build, like we did in the other one. And this is just going to be called build. Now, for those of you following along at home, there shouldn't be any code in this binary that has got anything to do with a specific EDA tool. I think. There's a statement for you. Because the assembly variant stuff is the thing that deals with all the EDA tool specific stuff. You know, like package and val and name and part and side and rotation and all this kind of stuff, right? At the time that all this information comes to us, we're just dealing with the output of that assembly variant process, which should all be normalized. Which is interesting with regards to the dependencies. And potentially, code should probably be in its own little crate. Anyway, so we're going to try and build stuff. Right. So we need a command. Amazing. And when the command is run, then it should fail at the moment, probably. Because we haven't done stuff. Let's just define what the expected output should be as being nothing, so that we can see it doing stuff. What? Sure. And we're going to need our build argument, I suppose, right? I forgot how to add arguments to the command. I think it's probably like with arg or something like this, but I don't remember. No, don't do that. Let's look for the build thing. Where is it? Build. So you create the command here, and then args are added when you run it, right? Args. So we want to do this, right? So you have to go .args with a list of stuff. Oi. Which is going to be build. And we're going to want to do some assertions on the trace log as well. So let's borrow this. I mean, do we do any assertions on the expected output? I don't think we do, actually. No. Let's get rid of this. We just care about the trace log. Okay, fine. So then we need our trace log argument. And then we need this whole build temp file thing. So where was that living? That was living here as well. So let's steal this and put that in this same thing here. Let's fix up these. So we need to know where tempter was coming from, which was this. And it feels like I probably cut that out of there a bit too early. Okay, right. What? Oh, because it's not public, probably. Yeah. And therefore we need a tempter, which is created like this. Oh, and now it needs that. Fine. And our test needs to return something because we use the question mark operator. Fine. Yoink. And we need to say okay at the end. There you go. And then we need the assertion on the trace log. Which means we need all this. Import that. Right. Right, great. So unexpected success. Because when we do build, it basically says, yeah, what did it do then? Wait. Yeah, what happened there? We do pass and it says okay. Oh, hold on. Well, should it succeed at the moment? It doesn't, honestly, it doesn't really matter. It's probably okay for the moment until we find something else to make it want us to fail. Right, but we didn't create any trace logs. Let's say, I don't know. What do we want? What do we want to do next? Let's try and do something useful. We've got the skeleton of all this ready to go. What do we want to do? Let's go back to our little diagram. Let me think about this. Essentially, what we want here is some sort of like grouping of, you know, these things. This way round. Yeah. Perhaps we need the concept of specifying designs. Because you can't have an assembly variant of a design unless you've got a design. And you need the design in order that so that you know the design extents before you can even think about putting it in a panel. But okay, so let's say we have an arg which is something like design, or maybe is it enough to specify an assembly variant? And somehow somewhere there's a reference to like some design or something. Let's think about this. Because we've got our assembly, which has got Do we have a definition of... Oh yeah, we've got assembly variant down here, right? And our assembly variant has a name. Oh, this lives in this. This is currently living in the EDA package. I'm not sure whether that's correct. I think I said that was when I was first thinking about this. Because, and then this correlates with what I was saying a minute ago, that this tool shouldn't care about anything to do with EDAs. But currently, assembly variant is living in the EDA package. There's a thought. So it probably needs to be moved into assembly. Let's see if we can move it and it makes sense to move it. Is there anything in here to do with an EDA? No. You've got a name and a refdes list. Yes, we're fine. Let's move it. Done. Let's run all the tests. Yeah. Okay, so clearly there's some stuff missing in one of these tests that we didn't run recently. Let's try running this. There's probably some imports missing from this. Yeah. Okay, fine. Let's try running all the tests again. Okay, and we've got our one failing test, which is what we want. So the moving stuff was fine. This is good. Arguably, you should do that move as part of like a separate commit to make reviewing easier. You know. Okay, so let's go back to this. So how about we say what I'm trying to work out is whether assembly variant should have some kind of reference inside it to the design. Whether a design should just be a design, an assembly variant should just be an assembly variant. And then there's something else which ties the two things together. Let's say I don't know. It feels like you need an argument where it's got two parameters. Both of these two parameters can be repeated multiple times because of the way that our relationship is here, right? So our job says, you've either got a panel, but the panel has got you've got panel positions and this is a nightmare. I think we need to go with the more complicated one first, so that all the data is structured properly. So if we take the scenario where we're trying to place a panel, let's go back to the scenario that we were looking at. The scenario that we're looking at is, say, this one, because it includes panels, designs, and assembly variants. And you're going to need to know the location, which position on the panel is which assembly variant, right? So you might say, I want 0 and 1 to be assembly variant A, and 1 and 2, 2 and 3 to be assembly variant B, and so. So let's think about that. Okay, let's go with that. I don't know. It's going to be foo. And we're going to say panel A. How do you define this? Should we say panels? Let's just go panels. Right? And let's have another argument later that ties it all together. And then we'll say let's just say variant. Let's say variant 1. Panel 1, variant 1. The names of these I don't care much about. And then we will somehow want to tie the variant to the design. I think the variant should probably know about the design or be able to look up the design that is for if it has the design name in it. Should it have the name in it, or should there be an ID? Should it be like this? Let's go with that for now. And then we want to say, I want this one, this panel index to be this variant. So let's say, what are the numbers of these things on the board on the panel? This will be now. Ideally, there'll be some nice little user interface GUI to help you build all this information up, right? Which is we'll build this later. We don't need it just yet. So I suppose if the first panel that you're specifying is panel 1, and the first variant that you're specifying is variant 1, then you could say panel position 1 is, yeah, let's say let's just say, I don't know, it's some kind of mapping, isn't it? And if we say panel 1 position 0 to 1 is gonna be you see, the problem is I've already got the name variant 1 here. So if I write variant 1 here, it might be a little bit puzzling. How about we go design variant like this, and then I can go design variant 1 like this. Yeah, okay. I mean, that sort of works, right? And then we want to say the same stuff again, but let's use human numbers 1 and 2, 3 and 4, 5 and 6. Yeah, so this panel, these positions, is this design with this variant, right? That sounds totally fine. Okay. Hmm. Yeah. Let's look at this again. One of the other scenarios, I want to think about this while I'm fiddling about with the arguments and so on like this. One of the other ones is free subjobs where, oh, yeah. Yeah, we got this subjob stuff. No, I think that's going to be okay. Probably going to be okay. So we got 6 identical PCBs in the bed, 3 variants, right? Let's see if what we came up with works for that scenario as well. So if we comment that one out and then say that there's no panels at all, how can we write this? Is there a mapping parameter? I guess is the first question. There's probably not, because this only applies to like the panels, doesn't it, right? Um, okay, yeah, okay. I think this is probably okay, but we're missing something here. When we did this, we need to say that this was supposed to be the other variant, and this was supposed to be the other variant, which means that we need these, right? So we're saying, I want a panel, and on that panel there is 1 design and 3 variants. Yeah, that works. And then we want the first 2 to be the first one, the second 2 to be the second one, and the third 2 to be the third one. That works. And if we didn't have this, you would need to specify something else. So the panel is going to need a location on the bed of the machine, right? But when you've got a panel, you don't need locations for the design variants because they're in the panel. So, I mean, so this is our sort of scenario 1. Let's create a new test. Build panel. Build panel with multiple design variant. Yeah. Okay, and then we've got build individually placed design variant. Okay. So we get rid of this mapping. Well, or do we? Do we? Let's call this panel mapping. And then let's think about this. So we've got the 3 designs, 3 variants for the same design. But we need to say there's 6 of them on the bed of the machine somehow, instead of a panel. So we've got no panel, goodbye panel. But we still need some kind of mapping. How about we say design mapping? Or design mapping? Something like that, but maybe not exactly. And now we've got our list of things like this, and if we said and each of these things is going to need a location. So if we say this, and then this, and then this, but and we'll deal with the locations in a bit. And if we just do this, how about we just do this? You know, just repeat the argument, you repeat the design variant multiple times. And then that is essentially our design mapping. Do we need... And if you specified a panel and you specified a panel mapping, that would all still work, right? Right? You could have one with all of them. Sure, why not? They're not mutually exclusive, are they? So you could have a panel and you could say, I want a panel mapping as well. Should we do the worst case scenario where there's 6 of them and a panel as our first sort of horrible test to write? Because that will then make us structure the arguments correctly, and then there's at least one test which says all of these arguments are completely valid and they're all valid together as well. Okay. Yeah. We could do that. I'm thinking that we don't do it now yet, though. I don't know, I kind of want to, but I also kind of don't. I'm kind of torn right now. Yeah, okay. Let's just put the... Let's just do it. Let's do it. Let's do worst case scenario. We build multiple panels with multiple design variants and individually placed design, individually placed design variants. Worst case. Oh, where did that go? So if we say panel 2, panel 1, panel 2, and then you've got the design variant. So these things need a location, and these things need a location. And when you're placing this panel, it has to use these, right? But that means because we've got 2 panels, it means we're going to need to duplicate this like this. Panel 2, panel 2, something like that. That's our horrible worst case scenario. Right, fine. Let's make that happen. Let's get rid of this test for now. That should be enough. And then later on we can specify, you know, you can load up some panel configuration from somewhere, given the name of the panel or something like that, right? And we can load up a design variant. Yeah, and we can load up design information based on its name from somewhere. Yeah, it kind of probably works. Let's make sure it runs. It runs, great. Okay, there we go. Unexpected argument, brilliant. So what we could do right now is start adding arguments, but I need some food. I need a break. I think that's probably enough for today. We've got a lot of the concept of what it is that we want to do sort of fleshed out a bit more and thought about, which is good. So we definitely need to do that. Now we can start sort of on the next stream, we can start adding some more of the detail about, you know, where all this stuff comes from and its implementation and so on. So that's what we're going to do. So yeah, just remember, folks, it's only software. How hard can it be? We'll find out on the next one. See you later.